Now, let's now see how we do count white blood cells. White blood cell count measures the number of white blood cells per liter, of course, or per microliter of blood. And we have to collect blood in EDTA tube, or we can use skin puncture, even if this is not actually a good technique for platelets. Of course, skin puncture is not good for platelet because skin puncture can induce platelet clamping. And if platelet clamping happens, so platelet report will not be accurate. So, but of course, using whole blood collected in EDTA tube can be a genuine process. And we have to dilute. We have to dilute the blood using weak acids. Mostly we use acetic acid or gracioacetic acid, or 1% hydrochloric acid, or you can use 1% buffered ammonium oxalate in order to prepare a dilution. And how do we dilute? To dilute RBC, the major, to dilute whole blood, the major purpose is to lyse red blood cells, to destroy red blood cell in order to avoid interference. Because when you don't lyse them, because we don't stain, they will look like white blood cell, and we may not be able to differentiate between RBC and white blood cells, and we may by mistake count RBC as white blood cells. So we have to avoid that interference by making dilution of 1/20 dilution ratio, which means we are going to take one part of blood into 19 parts of diluting liquids, which is either acetic acid, hydrochloric acid, or ammonium oxalate. So after diluting, we have, of course, to place the content up to 5 minutes or 10 minutes in order to wait for complete hemolysis. Then we take a small amount and we charge Hemacytometer using a charging device, or sometimes we can even use a micropipette to charge. We just charge Hemacytometer. You know how we do it. It's like we have to place cover slide on the Neubauer machine, and then we take a small sample and we charge from the edge of the cover slide, and the fluid will have to flow under or beneath the cover slide, and the cover slide is well charged without any air bubble, and that's when we can say this is actually well charged. And you have to charge both sides of the Neubauer counting area. And white blood cells are counted in 4 large corner squares, as we described, 4 millimeter square. Okay, that's why we count white blood cell from here. So we have to charge from this end. We charge from this end, and the sample will flow beneath the cover slide. And we are going to charge also this area, and we charge from this end. We charge from here, and the sample is going to flow under the cover slide, and then both areas are charged with a similar specimen. So the procedure is to clean a Hemacytometer and the cover slides with alcohol, or of course you can use a new one. Of course, the Hemacytometer can be reused, but of course cover slide we have to use new. It is good to use new cover slip or cover slide. And then we prepare 1/20 dilution by mixing at least 25 microliter of blood with the 475 microliter of whole blood diluting fluid. Of course, it can be like oxalate as ammonium oxalate. It can be gracioacetic acid. It can also be hydrochloric acid. So in this case, this depends on the amount we want to mix with. So it depends. Here is when you want to prepare 500 milliliter, but you can even prepare 100 milliliter by taking 5 microliter of blood in 95 microliter of diluting fluids. So then after that, we have to cover and mix the tube by inversion and allow to stand for 10 minutes in order to allow RBC complete lysis, and mix again and fill a microhematocrit tube with diluted sample. So this is we can use microhematocrit tube, or what you call filling or charging apparatus. Sometimes we have been using, even if you don't have this one, you can still even use micropipette. You can take a small sample in micropipette and charge the hemacytometer. So charge both sides of the hemacytometer by attaching the tube tip to the cover slip edge. That's what we do. We have to touch the tube tip to the cover slip edge at 400 and at 45 angle degrees. So that's how we do it. Place in a moist chamber for 10 minutes to let the cell settle. Sometimes if you don't have a moist chamber, you can still even do it. You can even place it on the bench, on the table that you are using. That's okay. Because for 10 minutes or 5 minutes, every cell will have settled down, and keep in horizontal and place it on microscope stage, the entire hemacytometer. Then lower the condenser and focus 10 objective. This is the lowest magnification, of course. That is lower power field, 10 objective. And then make sure that the cells are evenly distributed. So for 1/20 dilution, count cells in the 4 corner squares, including those on the top and left line only. So don't count the cells that touch the right line and the bottom line. For example, this is how they look like. They look like this one when you are counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. Maybe you count 15 here. Okay? Maybe this is the first one. Maybe this is the first corner square. Okay, you see we have one corner square, which is 16 smaller squares. 1, 2, 3, 4. 1, 2, 3. So this one is cut from down. Okay, but it has to have 4 and then 4, because it should look like this one. 1, 2, 3, 4. 1, 2, 3, 4. And this is a one corner square we are counting from. So in fact, which cell do we count? For example, consider this one is a left. This one is a left. Is left. Left corner square. We have to count every cell that touch left line and top line, but we don't count a cell that touch right line and bottom line. We don't count it. I'm going to show you why we don't count this one. For example, let's say we are counting this one. Let's say we're counting this. This is a left upper corner square. Left upper corner square. We are counting every cell that touch this line and this line, but we don't count cell that touch this line and this line. Okay, because when you count this one that touch here, you are going to also, this cell that touch here is shared by this square and this square. If the cell touches the bottom line, it is shared by this one and this one. So we don't count them. We just ignore them and count any cell that touch here or here. But what is outside, we also don't count it. Okay, the same as here. From here we count from there and there, but we don't count here and here. So that's how this is the counting protocol of the cell. So repeat count on the opposite chamber side. So as I said, you have to count on both sides of the hemacytometer, and the difference should be at least less than 10%, which means that this should agree within 10%, or the count should agree within 10%. For example, if you count 90 cells on one hemacytometer chamber, okay, and you count 115 cells on the second hemacytometer chamber, that should be repeated. You cannot use that one. You have to repeat the procedure, because that means the cells are not well distributed. So they should agree within 10%. So it means if it is 90 cells in one chamber, then it should be at least within 81 up to 99. So they should agree within 10%. Okay. Average the white blood cell counts from both sides and calculate the final white blood cell count using a standard formula we have used. So just do average. For both sides, you calculate average like this. So we are going to use this example in order to understand it better, how it works. dilute 1/20 of blood using, of course, diluting its fluid. We have talked about them. Counts from one side are 23. So 23 means from one corner square, 26 from the second corner square, 22 from the third bottom corner square, and then 21 from the fourth bottom corner square. Total count out of 4 corner squares is 92. Okay, and from the second side of the chamber, you get 28, 24, 22, and 26, and the total is 100, and the difference is less than 10%. So which means two corner squares, I mean two counting chambers, agree within 10%, because here we have 92 and we have 100. So then after you calculate the average is 96. So this average value is then used in white blood cell count formula for final calculation. So we don't use 92, we don't use 100, but we use 96 as the average. So if they don't agree within 10%, of course, we are going to repeat the whole procedure. So white blood cell count is cell counted, which is 96, times dilution factor, which is 20, because it is 1/20, over area, which is 4 millimeter square, because we have counted from 4 corner squares, times 0.1, which is the distance between cover side and the slide and the counting area. And it gives us cells per microliter or millimeter square, millimeter cubed. That is 4,800 cells per microliter. If you want to convert it to per liter, like in most of our labs, we use per liter. So you report them as 4.8 times 10 power 9 per liter. So that is what we use in total as white blood cell. That's the formula. That is the same formula is used also for platelets and for RBC, but the difference is that we don't use the similar counting area or similar diluting factor, because for platelet we use 100, 1/100, the dilution factor or diluting ratio. Sometimes, in case the patient is having low counts, even if whether it is low count or it is high count, you can dilute it 100. We can still use the same dilution factor 1/100, even for WBC. And then if we use this 1/100 the dilution, we are going to use all 9 large squares. We are going to count from the entire surface, from the entire counting chamber on both sides. So then it means you'll be counting over 100, 9 millimeter square, and then you are going to use the formula. For example, if the average count is 54, so then the value is applied in white blood cell count formula, and we use a cell counted, which is 54, times dilution factor. Of course, it is 100, because we are using 1/100 over 9. 9 is because we have chosen to count over the entire surface, which is 9 millimeter square, times 0.1, and then it gives us around 6.0 times 10 power 9 per liter. That's also another alternative we can use if we choose to use 1/100 dilution. So source of error for WBC counts: clean the hemacytometer and cover slide and avoid dust, because dust can cause problems. If the sample or hemacytometer machine is dusty, the dust can appear as if they are cells. Ensure that dilution fluid is contaminant free, and for low count, increase counting area, improve accuracy. If you see that cells are very few as you are counting, it is advisable to increase counting area from 4 millimeter square up to 9 millimeter square. proper chamber charging is a very essential. You must avoid overfilling and you must avoid underfilling in order to avoid an even cell distribution. To avoid overfilling and avoid underfilling of the counting chamber, to avoid problems of cell and even distribution. Allow 10 minutes to settle for the cells before counting in order to avoid movement, because cells can be moving, and it can be challenging. So sometimes one of the challenges that we're also facing is that NRBC are not raised. NRBC, it is a nucleated red blood cell. NRBC are not raised by diluent and are counted as white blood cells on the hemacytometer. So when you suspect that patient has nucleated red blood cell, what do? You have to do what is called corrected white blood cell count. And you see this formula is very useful in your exam. Sometimes we find that you're given this question in exam, and they're giving you what you call uncorrected white blood cell count, and they're asking you to calculate corrected WBC. So how do you correct? Because this person is having nucleated RBC, and those ones are not raised properly. So they can stand, they can still be appearing even after mixing with lysing agents. So in that case, you have to prepare peripheral blood smear along with this manual hemacytometer. You must prepare a peripheral blood smear. So peripheral blood smear is prepared the same way. You have to stain it, and then you have to examine under oil measuring objective, and then after that you can use then corrected white blood cell. That means you are going to calculate. You are going to count 100 white blood cell on the peripheral blood film after staining. Then you also count the number of NRBCs as you are counting white blood cell. So when you reach 100 in total, then you stop. Then you will count how many NRBCs out of 100 white blood cell on the peripheral blood film under staining. That one then is used in a formula. Then you are going to call it uncorrected white blood cell count, which means this is the number of white blood cell you have counted on hemacytometer, because it is not corrected, because it contains also some of the NRBCs in it. So it is called uncorrected times 100. So 100 is in the formula over number of NRBC per 100 WBC plus 100. Okay, which means number of NRBC per 100 white blood cells means the number of NRBC that you counted on peripheral blood film stained times plus 100 also the formula, and what you get here is what we call corrected white blood cell count. So don't forget this formula, because you may see questions in your exam where they will ask you to calculate corrected, and calculations in hematology is something real, very real in exam. So you have to try to not to forget this. It is very, very, very useful. Try not to forget this. Then you use the formula in case you are given